Good afternoon, all. This is Satish Kumar, Assistant Professor of EC Department. Now, let us see the another video lecture series on LTI discrete time systems. That is nothing but difference equation. See, this is the empathy part of difference equation. Why difference equation? It is the foundation of understanding the digital system behavior, connects the input and output signals in terms of discrete time systems. It is used in digital filters, control systems and DSP hardware. Why it is a system blocks with arrows showing input shows the system as output. That is nothing but excitation. Next one, empathy. Difference equation can be applied with real world motivation. It is used in DSP filters, that is for FIR and IIR filter realizations. See, realizations are direct form 1, direct form 2, cascade form and parallel form. It is used in control systems for controlling using the discrete laws. And it is used in communication systems for adaptive equalization in communication, audio processing, systems for creating echoes and reverse systems. Next one, define difference equation. It is an efficient way to implement discrete time systems. The convolution of the input sequence x of n and the unit sample response h of n gives the output as y of n. Y of n is equal to summation k is equal to minus infinite to plus infinite x of k into h of n minus k. Next one, this is the defined part of system response realization. It is the order highest delay term in y of n or x of n, output function or input function. It is a homogeneous part that relates the system natural response, and a particular part represents forced response due to input. And we calculate the system transfer function of the difference equation. Next one, ideate Z transform. We are applying the Z transform to the discrete time systems for analyzing the discrete time systems. Z transform is used for analysis of discrete time signals. It is more broad compared to DTFT, that is nothing but discrete time Fourier transform. It is very much useful in discrete time systems as well as system analysis. X of n and X of Z forms the Z transform pair. This is the imaginary axis into real axis and real axis into imaginary axis. See, imaginary of S, it can be represented in terms of Laplace transform that can be converted into Z transform with the help of unit circle. Next one, ideate system transfer function, that is ratio of the output to the input. H of Z is equal to Y of Z divided by X of Z. Next one, frequency response. How a system responds to different frequencies? H of omega is equal to Y of omega divided by X of omega. Next one, ideate solving differential equations. First, direct method, step by step substitution, and then we are applying the Z transform method, convert to algebraic equation, and then flow of equation in terms of Z domain. We are applying the inverse Z transform, we can get the output. This is the difference equation flow. First, for the given difference equation, we are applying the Z transform and then find out the system transfer function, that is nothing but Y of Z divided by X of Z. For that, we are applying the algebraic equation and solving for roots. Finally, we can apply the inverse Z transform. We can get the impulse response of the discrete time system. Next one, mind map. It can be mind map with the real world integration. That is nothing but FIR, IIR, filter implementation, adaptive systems and echo cancellation, DSP, architecture design and innovation. Difference equation are the backbones of digital system design. We are using the finite impulse response and infinite impulse response filter implementation, adaptive systems and echo cancellations for discrete time systems, DSP architecture design for designing to realize the discrete time systems, innovation visualize the output using real-time signal data. Next one, we can see the assessment, define difference equation. Difference equation relates the input and output of the system. Y of n is equal to summation k is equal to minus infinite to plus infinite x of k into h of n minus k. List the applications of difference equation. It is used in DSP, filters, control systems, communications, etc. Infer system transfer function. See, system transfer function is defined as the ratio of the output to the input. It is defined as h of z is equal to y of z divided by x of z. list the steps to find the impulse response of the system. First, from the difference equation, we are applying the Z transform, and then we can calculate the system transfer function, and then solving for roots, and then we are taking the algebraic equation, and we can apply the inverse Z transform. We can get the impulse response of the system. What is mean by unit impulse signal? See, unit impulse signal can be represented by del of n. Del of n is equal to 1 for n is equal to 0. 0 for n should be not equal to 0. Interpret Z transform. Z transform is used for analysis of discrete time systems and signals. It can be defined as x of z is equal to summation n is equal to minus infinite to plus infinite x of n into Z bar minus n. See, Z transform plays a major role to identify the difference equation of the discrete time LTI systems. Thank you.